Hi guys, Jeremy here again, Tactical Classroom. Today we're going to be taking a look at one of many wind formulas that as long range shooters we employ to give us I suppose, a quick and dirty adjustment or hold to account for wind deflection. Today's wind formula that we'll be looking at is known as the rule of 9's. And it works really well for those of us that employ mills or mill-rad scopes. So by way of lesson overview, today's going to be a PowerPoint lesson explaining the concept of the rule of 9's and of course how to use it. We'll have some some practical exercises included during the lesson, so make sure you've got a pen and paper ready. Generally these formulas are designed so that they can be done in your head, but if you're just getting to grips with the formula, sometimes it pays just to write things down, take some notes, just until you get your head around it. By way of lesson objectives, by the end of this lesson you'll be able to demonstrate an understanding of the rule of 9's wind formula and how to use it to quickly account for wind deflection. So what are we talking about when we talk about wind formulas? Well, as a general rule, wind formulas are designed to be quick and easy formulas that are easy to remember and that allow a shooter to quickly determine an approximate windage adjustment or mill hold or MOA hold to account for wind deflection. With wind formulas, simplicity is king, so most of them will avoid complex mathematics and stick to elementary school, junior high school sort of level mathematics. So we're talking times tables and stuff, pretty basic stuff. In terms of limitations, they're not minute of angle accurate, so probably not ideal for competition shooters. However, they are minute of man accurate or minute of bad guy. That's often how they're referred to. But in saying that, they are still pretty close, especially if you tweak them so that they correspond to your personal rifle ammunition data. So you normally get a solution that is within a click or two. So at the end of the day, when we're making a wind call, we'll use that wind call in the formula. So if we're out by a little bit with our wind call, we're going to be slightly out with our hold or our windage adjustment. So at the end of the day, our wind call's a best guess. So if we are out by a little bit, was it our wind speed, or was it our wind speed estimate, or was it the formula? So I mean, as I said, it's not minute of angle accurate. So if you're looking for precision, if you're a competition shooter and you've got the time, of course you're gonna rely on accurate ballistic data that you've got recorded. If needs be, you can get out a calculator and take the time to do the finer detail type stuff. But these wind formulas are generally very good for circumstances where you don't have huge amounts of time. So if you're doing some long range hunting or just hunting in general, and you want to take into account wind, you can do it quick and easily using this formula. Same concept applies to law enforcement in a tactical environment, or or military. These formulas are good enough to get you on. So let's crack on. So how it works, the rule of 9's formula was developed for military 308, 762 sniper ammunition, and it's based on the fact that in a 9 mile an hour full value wind, that projectile is deflected by 1/4 of a mil or 0.25 of a mil at a distance of 100 meters. Okay, so the constants that you can find them on the internet and stuff like that. They don't necessarily match what I've got down here below, but that's because I've tweaked the constants so that they match my my rifle ammunition combination data, so they're more accurate for me than the stock standard formulas and constants and stuff that you will find on forums and so on and so forth. So yeah, it's the rule of nines. It's also based on those constants, which in turn are based on the range to target and of course your data. So I mean, it's pretty simple. 100 meters gives you a constant of 1, 200 meters gives you a constant of 2, 300 meters gives you a constant of 3, and so on and so forth until you hit 600 meters, at which point things start to change. So at 600 meters, the constant changes to 7. At 700 meters, it's 8. It's 8. 800 meters, we're looking at 10. 900 meters, we're looking at 12. And 1,000 meters, we're looking at 14. Now, as I said, those have changed slightly to what you'll find, the average, I suppose, constants that they put up on forums and things, and that's because I've manipulated these constants so that they match my range data for my rifle and ammunition combination. So let's take a look at some examples. So in this example, we've got a 7 mile an hour wind at 500 meters. So we take our wind speed, which is 7, and multiply that by our constant, which for 500 meters is 5, which gives us an answer of 35. Okay, and then it's simply a case of how many nines fit into 35, or a number close to 35. Okay, so in this instance, 9 multiplied by 4 gives us an answer of 36, which is close to 35. So 4 becomes our magic number. Okay, and so because we know that 9 equals quarter of a mil, we go quarter of a mil multiplied by our magic number of 4, and we get an adjustment or a hold of 1 mil. Hopefully that makes sense to you. If not, hopefully by the end of this example you will have a good understanding of what I'm trying to explain. So in this example, we're dealing with a 12 mile an hour wind at 700 meters. So we've got 12 multiplied by 8 equals 96. Okay, so how many 9's fit into 96? Well, if we go 9 multiplied by 11, that's 99, so that's pretty close. So 11 becomes our magic number. So quarter of a mil, or 0.25 of a mil, multiplied by 11 gives us 2.75 mils. And I've got light there because 99 is a little bit more than 96. So you could probably drop that to 2.7, something like that. But it'll get you close enough. So it should be fairly clear. Hopefully by the end of these questions, you'll be fully across it. But this is up to you now. This is your turn. So I'll run you through the questions. Once you've heard the question, pause the video. Do your formula, whether you do it in your head, whether you do it on a bit of paper with a pen until you feel comfortable enough to do it in your head, and then just unpause the video, check your answers with mine, and all going well, you should have the same sort of answer as me. If not, rewind the video and keep going till you get it right. But anyway, your turn, guys. So question 1. Let's say you're dealing with a 3 mile an hour wind at 400 meters. What is your adjustment / hold for wind deflection? So pause and then come back to me once you've got an answer. Alright, so first number 3. It's our wind speed. So 3 multiplied by our constant, which is at 400 meters, 4. So 3 multiplied by 4 gives us an answer of 12. How many 9's going to 12? Well, 9 times 1 equals 9, which is close enough. Therefore 1 becomes our magic number. So 0.25 of a mil multiplied by 1 is 0.25 of a mil. Obviously 12 is a little bit a slightly larger number than 9, so drop that 0.25 to 0.2. question 2. Let's say that you're dealing with a 5 mile an hour wind at 600 meters. What is your adjustment / hold for wind deflection? Pause the video at this point, run through your formula and then come back to me and check your answer against mine. Right, so wind speed, 5 multiplied by the constant. At 600 meters, we're looking at a constant of 7, so 5 multiplied by 7 equals 35. Okay, 9 multiplied by 4 equals 36, which is close enough to 35. So then it's just a simple case of 0.25 of a mil multiplied by our magic number of 4, which gives us a hold or an adjustment of 1 mil. Right, final question for you guys. Let's say you're dealing with a 10 mile an hour wind at 1,000 meters. What is your adjustment / hold for wind deflection? Once again, pause the video at this point, run through your formula, and then unpause the video and check your answer against mine. So we've got a 10 mile an hour wind multiplied by our constant, which at 1,000 meters is 14, which gives us an answer of 140. So 9 multiplied by 16 equals 144, which is pretty close. So 16 becomes our magic number. So 0.25 of a mil multiplied by 16 gives us an answer of 4. But because 144 is a little bit more than 140, you're on the lighter side of 4 mils, so maybe 3.9 or whatever. Okay, just to show you, give you an example. If we go 9 times 15, for example, is 135. Okay, so 135, also close to 140, but just slightly, it's like one number more than 144. So not a lot in it. 140 kind of sits bang in the middle. So if we use 15 as our magic number, 0.25 multiplied by 15 equals 3.75 mils. So a light 4 mil hold of say 3.9, and it's pretty much bang in between those two. So you're going to be on. Now just to give you an example of how this works in terms of how it relates to my data. If I just escape out of there, bring up my applied ballistics solver. So shooting 168, grain 308. Got all my environmentals in here, and we've got a 10 mile an hour wind. So I've got a range card here, and if I come down to 1,000 meters and scroll across to my windage, 3.98. So it's pretty damn close to our answer of sort of 3.94. Yeah, so I mean they're pretty damn good, and that's based on my own data, obviously. Now, if you wanted to tweak the constants, you produce yourself a range card, so you know what your windage adjustment is for a given range. So you want to work out your 1,000 meter. So you come in here, 10 multiplied by 14 equals 140. So if I change that constant to 13, I'd have a different number here, and my end result down here, the 4 mils, would end up at something different. So what I'm trying to do is get my end result matching, matching this number here, my windage at that range. So just by tweaking those, going through the formula and just tweaking the constants until such time as your answer matches your range card data, and then you'll be sweet. So for your ammo type, your constant might be 13, it might be 12, whatever, but you can just run through the formula, like I said, until such time as the end result matches your range card data, and then you're good to go. Right, so let's carry on. So by way of recap, in this video we looked at the rule of 9's. We talked about its limitations, i.e., you know, it's not minute of angle accurate, but it's pretty close. And of course we looked at how to use the formula, how to run through the formula. I then took you through some examples of the formula being used before we cracked on with some practical exercises that you guys undertook, and hopefully had some good results with. By way of conclusion, you know, at this point, you should be in a position where you can explain the rule of 9's to someone else, and you can explain the limitations of the rule of 9's to that person. You know, you've demonstrated the knowledge of the rule of 9's practically by undertaking those practical exercises during this video. If you struggled with it, you know, go back, watch the video again. If you're still struggling, you know, flick me an email, jeremy@tacticalclassroom.com, and I'll try and help you out. But it shouldn't be too hard. I like to think that there's enough explanation in this video to get you where you need to be. So, you know, you've demonstrated your knowledge by doing those examples during this video. All you got to do now is transfer what you've learned here out onto the range. Okay, and you've done the formula. It's not hard. It's not complicated. The tricky thing once you go outdoors onto the range, you know, the tricky thing there is reading the wind and putting an accurate wind speed into that formula. You know, if you get the wind speed wrong when you're entering into the formula, of course the output's going to be incorrect as well. So it's like anything we do with long range shooting, you know, you've got that critical factor being the wind. So if you can get that as accurate as possible, then your formula should work out pretty damn good. Okay. Question time. So if you've got questions, feel free to leave questions below this video. Otherwise, flick me an email, jeremy@tacticalclassroom.com. Alternatively, head over to the website, go to the contact form, and send me an inquiry through there. Okay. I really hope you found this video beneficial. You know, it's one of many that we'll be looking at over the next little while. We've got another one coming up shortly, the British method, which is very similar to the rule of 9's, and works well with those using minutes of angle. Okay, and we'll also look at another one based on the BC of your bullet. So we've got plenty more wind formula videos to come. This is one of many. So I hope you found it beneficial. If you did, I'd really appreciate it if you could you know, give us the old thumbs up. You know, like the video, share it with friends of yours that could benefit from watching it. Okay, and other than that, wait out for the next one. Take care, and I'll see you around.